Welcome. This is another video based upon equation of a straight line, but here we are going to deal about what is this parallel lines, perpendicular lines, and neither. When are the lines are parallel? If the gradients are equal. Remember, if the gradients are equal, we'll try to find the gradients, and if they are equal, then they are parallel. Or if the product of the gradients is -1, then it is perpendicular. Remember, the gradients are equal, it is parallel. If the product of the gradients is equal to -1, it is perpendicular. And if both the cases are not satisfied, then it will be neither. So for the first part, part A, the gradient of the first line is 4. Always compare with y equals to mx plus c. M is going to be the gradient. Gradient of the first line is 4 and gradient of the second line is -1 upon 4. And we can see that m1, m2 when I multiply, it's going to be -1. So m1, m2 equals to 4 times -1 upon 4, which is -1. So therefore they are perpendicular. So I'm going to write it as they are perpendicular. Perpendicular. Now coming to part B, gradient of the first line is 2 upon 3 and gradient of the second line is also 2 upon 3. M2 is also 2 upon 3. They are equal. M1 equals to M2. So therefore they are parallel. Now coming to part C, gradient of the first line is 1 upon 5. M1 equals to 1 upon 5 and M2 equals to 5. Are they equal? They are not equal. If at all I multiply them, am I getting -1? Not -1. So it's going to be neither. They are not equal and product is also not equal to -1. Now coming to part D, E and F. So let me copy that one there and over here D, E and F. Now in this case m1 equals to -3, m2 equals to 1 upon 3. So m1, m2 when I multiply, -3 times 1 upon 3, which is -1. So therefore they are perpendicular. Part E, m1 equals to 3 upon 5, m2 equals to -5 upon 3. Multiply m1 times m2, 3 upon 5 times -5 upon 3, which is -1. So therefore they are perpendicular. If the product is -1. m1 equals to f 5 upon 7. m2 is also equals to 5 upon 7. m1 equals to m2. So therefore they are parallel. Now coming to the next question, GHI. I start a new page there, GHI. For G, m1 equals to 5, m2 equals to, formula is minus a upon b. A is 5, b is -1, which is also 5. So m1 equals to m2. So therefore they are parallel. Now for H, m1 equals to minus a upon b, which is 5. m2 equals to -1 upon 5. Then m1, m2, multiply it out, 5 times -1 upon 5, which is -1. So therefore they are perpendicular. Now m1 equals to -3 upon 2. m2 equals to minus a upon minus b. So which is 2 upon 3. So m1, m2, which is -3 upon 2 times 2 upon 3, which is -1. So therefore they are perpendicular. If the product equals to -1, they are perpendicular. And finally, JKL. JKL, m1 equals to -4 upon -5, which is 4 upon 5. m2 equals to -8 upon -10, which is again 4 upon 5. m1 equals to m2. So therefore they are parallel. Now for this one, m1 equals to -3 upon 2. m2 equals to -2 upon 3. m1 is not equal to m2 and when I multiply also, I'm not going to get -1. So therefore, it is neither. M1 equals to -5 upon -1, which is 5. M2 equals to -2 upon 10, which is -1 upon 5. We can see that when I multiply them 5 times, -1 upon 5, which is -1. So therefore, they are perpendicular. Question number 2. Find an equation of a line that is passing through the point 6, -2 and perpendicular to the line. So what is the gradient of the given line? Gradient of given line. Gradient of given line is 3. So I want perpendicular. So what is perpendicular gradient? Perpendicular gradient will be, do the reciprocal and change the symbol y minus. So 3 upon 1 will become 1 upon 3. Now I ignore the point, I know the gradient. So y minus y1 equals to m times x minus x1. So y plus 2 equals to -1 upon 3x plus 1 upon 3 times 6 is 2. I think so. You can cancel 2 and 2. So what am I going to get it out? I am going to get y equals to -1 upon 3x. That's going to be the answer. Next, question number 3. Find the equation of a line that is passing through -2, 7 and parallel. So what is the gradient of this line? Gradient of this line is 4. Parallel means the gradient will remain same. Then y minus y1 equals to m times x minus of x1. So y minus 7 equals to 4x plus 8. So y equals to 4x plus 8 plus 7. So what does that becomes? Y equals to 4x plus 15. But we need to write it out in this standard form. Bring the y also to the other side. 4x minus y plus 15 equals to 0. Question number 4. Find an equation of a line parallel to. Parallel to means we have to keep the same gradient and use this point. So y minus y1 equals to m times x minus x1. So what does that becomes now? Y minus 3 upon 2 equals to -2x plus 1. So when I simplify that, I am directly writing the answer y equals to -2x plus 1 plus 3 upon 2. You can use the calculator to get that answer. -2x and this is going to be minus of minus plus, so this one is going to be -1. So this is also changes to -1. So it is plus 1 upon 2. Now coming to part B. Parallel means the gradient is going to be the same. What is going to be the gradient? Gradient is m equals to minus a upon b, minus 1 upon minus 2, which is 1 upon 2. So the y minus y1 equals to m times x minus x1. So y equals to half x. Part C, perpendicular. So what is the gradient? Gradient is 1. So perpendicular gradient will be reciprocal and change the symbol -1 and passing through -1, -2. So y minus y1 equals to m times x minus x1. So y plus 2 equals to -x, -1. Y equals to -x, -3. Then part D, again perpendicular and passing through this. So what is the gradient of this line now? So let's start a new page there. So part D, gradient of the given line, 2x plus y minus 9 equals to 0. So the gradient of the given line is minus 2 upon 1, which is minus 2. So perpendicular gradient will be 1 upon 2. 1 upon 2 and passing through what is the point? 4 comma -6. 4 comma -6. So y minus y1 equals to m times x minus x1. So y equals to half x. Minus 4 upon 2 is 2. minus 6. So what is that equation? Y equals to half x minus 8. Question number 5. Find an equation of a line parallel to gradient is 3. So the other gradient also will be 3 and passing through 5. So y minus y1 equals to m times x minus x1. So y minus 5 equals to 3x plus 6. Y equals to 3x plus 6 plus 5. So y equals to 3x plus 11. Next one, perpendicular. Gradient is 3. So our other gradient will be minus 1 upon 3. So y minus y1 equals to minus 1 upon 3 times x minus x1. So y equals to negative 1 upon 3x minus 2 upon 3 plus 5. Use a calculator. You should be able to get that answer as 13 upon 3. Next, parallel to this line. So what is the gradient of this one? Minus 4 upon minus 6, which is 2 upon 3, which is nothing but how much? 2 upon 3. So the gradient is 2 upon 3. So y minus y1 equals to 2 upon 3 times x minus x1. So y minus 4 equals to 2 upon 3x minus 6 upon 3 is 2. So y equals to 2 upon 3x minus 2 plus 4. Y equals to 2 upon 3x plus 2. Now part D, perpendicular. The gradient of this one is 2 upon 3. So the perpendicular gradient will be minus 3 upon 2 and x minus x1. So y equals to minus 3 upon 2x plus 9 upon 2 plus 4. So it becomes y equals to minus 3 upon 2x plus 17 upon 2. Question number 6. Find the equation of a line which passes through the point and is perpendicular to this one. So what is the given gradient? Given gradient is 2 upon 3. But he says it is perpendicular. So what is perpendicular gradient? Minus 3 upon 2. So y minus y1 equals to m times x minus x1. So y equals to minus 3 upon 2x plus 15 upon 2 minus 5. So y equals to minus 3 upon 2x plus 5 upon 2. So multiply entire equation with 2 because I want in the standard form. So it will become 2y equals to negative 3x plus 5. So 3x plus 2y minus 5 equals to 0. Question number 7. Equation of a line that passes through minus 2 comma 3 and perpendicular to. The given gradient is minus 4 upon 7. So perpendicular gradient equal to 7 upon 4. So y minus y1 equals to m times x minus x1. So y equals to 7 upon 4x plus 14 upon 4 minus 3. So y equals to 7 upon 4x plus 1 upon 2. This is 14 minus 12 is 2 upon 4. 2 upon 4 is 1 upon 2. So what I can do it is I multiply by 4 on both sides. So 4y equals to 7x plus 2. So 7x minus 4y plus 2 equals to 0. Question number 8. The line R passes through these 2 points, S passes through these 2 points. Show that they are parallel. So I find gradient of line R. y2 minus y1 upon x2 minus x1, 4 upon 5. I find gradient of S. y2 minus y1 upon x2 minus x1, 12 upon 15, which is again 4 upon 5. We know that MR equals to MS. So therefore, they are parallel. If they are equal, they are parallel. Next, question number 9. L passes through the points and N passes through the point. Show that N and L are perpendicular. So M of L. y2 minus y1 upon x2 minus x1. So which is negative 2 upon 6, negative 1 upon 3. Then Mn. y2 minus y1 upon x2 minus x1. minus 6 upon minus 2, which is 3. We see that m1 times m2, negative 1 upon 3 times 3, which is negative 1. If the product of slopes is negative 1, they are perpendicular. Question number 10. Last question. Show that these are the vertices of the quadrilateral is a rectangle. We have to prove that it is a rectangle. So what am I going to do? I am going to draw a rectangle over there. A, B, C, D. A is negative 1, 5. B is 7, 1. C is 5, negative 3. D is negative 3, 1. So I will be finding gradient of AB. 1 minus 5 upon 7 minus of minus 1, which is nothing but how much? Negative 4 upon 8, which is negative 1 upon 2. Then I'll find gradient of BC. It should become 2. 1 minus of minus 3 upon 7 minus 5, which is 4 upon 2, which is 2. We can see that MAB times MBC, which is negative 1 upon 2 times 2, which is negative 1. Therefore, they are perpendicular. These two are perpendicular. Then I'll be finding it out MCD. MCD. So gradient of CD. When I find the gradient of CD, minus 3 minus 1 upon 5 minus minus 3. 5 minus minus 3, which is nothing but what? Negative 4 upon 8, which is negative 1 upon 2. We can clearly see that MCD and MAB are equal. MAB, gradient of AB and gradient of CD are equal. So therefore they are parallel. So these two are parallel lines. These arrow marks indicate they are parallel. So this angle also has to be 90 degrees. So, and finally I'll be finding it out, gradient of AD. AD, which is 5 minus 1 by 5 minus 1 by minus 1 minus minus 3 minus 1 minus minus 3, which is 4 upon 2, which is again 2. We can clearly see that MBC should be equals to MAD. So MBC equals to MAD. So they are parallel. So opposite sides are parallel and the angles are 90 degrees. Therefore ABCD is a rectangle. So that completes this video. See you in the next video. Bye.